introduction, and thanks again to GCA and NAU for hosting this event and providing us a place to have this. I will be going through a few things this evening. First of all, I'm going to give a brief lesson in landscape ecology, a field of study that some people may not be familiar with. I'll talk about the diversity of Grand Canyon resources, and then I'll describe our Watershed Stewardship Program, and we'll go into detail on two projects that we're working on, including the Greater Grand Canyon Landscape Assessment and the Granite Camp Monument Creek Pilot Stewardship Project. So landscape ecology, like I said, is a relatively new field. It's focused on the spatial components of ecosystems. And I learned this kind of basic concept in a landscape ecology course I took as an undergraduate. And this framework has been really useful for me in my professional career and trying to look at the natural world and seeing how things relate to each other. You'll see in this picture, I've got the pattern up here, and you just have a picture of a burned ponderosa pine forest. And then you have a process, which is fire. And we'll just use that as an example to walk through this. Pattern and process go hand in hand. They interact with each other. And the way they interact with each other is both through the abiotic template, so the physical template, and the biotic template. So those are those things in our world that have carbon. And if you imagine a fire going through a forest, the fire is the process, and its influence, its behavior is influenced by both the abiotic template, so thinking about topography, slope, aspect, and also the biotic template, what is living there, what the trees are, what their density are, fine fuels, coarse fuels, those types of things. And not only do you have that interaction occurring, going back and forth, but you can also have positive and negative feedback loops in any of those systems. Any given pattern and process relationship can occur over short to long time periods and also over fine to coarse spatial scales. And I'm just going to walk you through, try to provide a framework for this concept, walk you through a few examples, and hopefully that'll provide a context for the rest of my talk. So, at the big scale is a macrocosm. The first time I ever saw an image from the Hubble Space Telescope, it blew my mind. This image was taken years ago, but it encompasses a field of view that is equivalent to looking at the width of a dime at 75 feet. So this is a really, really narrow patch of sky. And this field of view encompasses 1,500 galaxies. So if you remember back to grade school science, we live in a solar system. Our solar system is one of potentially billions of solar systems in the Milky Way galaxy. And the Milky Way galaxy is one of billions of galaxies in the universe. And this picture alone has 1,500 galaxies. The time I saw an image like this, it really got me thinking about our place in the world, and it makes you feel pretty insignificant. So at the other end of the spectrum is a microcosm. This is a picture of a buttongrass moorland in Tasmania. This is one of the sites where I did my doctoral research studying the effects of fire on birds. And one morning I came out to this site and it was covered in dew. And it was beautiful, and I looked out and I just saw thousands of spider webs. Oops. Just covering the site. And I'd been at the site many times, and I was mostly focused on the birds and never really bothered to think what was underfoot. Well, I was stepping on thousands of spiders and insects, and as part of my study, I also used a vacuum sampler to assess the potential prey availability for insectivorous species of birds. And based on that sampling, there might be like on the order of 1,000 invertebrates, arthropods, in a square meter. And if you scale that up, so you've got 1,000 per square meters, that's about 400 million arthropods in this little patch of ground, which is pretty amazing. Now, when I was vacuum sampling those arthropods, not only do you suck up a bunch of those arthropods, but you suck up other things like wombat turds. And my fun fact for the evening is that wombat turds are cubes. They actually have 4 sides, Apparently, when people first came to Australia, they would use them as dice. And they say you can't fit a square peg in a round hole, so how do you get a square scat out of a round hole? I'm not quite sure, but yeah, that'll be another step of research in the future. So now that we've got kind of a frame for spatial scales, let's talk about temporal scales. And here's a cross-section of Grand Canyon, which many of you are probably familiar with. And the oldest rocks, the Vishnu Schist and Zoroaster Granite, are about 1.8 billion years old. If there are any geologists in the audience, I don't really want to argue with you. It could be plus or minus a billion years, it really doesn't matter. The Kaibab limestone, which is the top main layer you see of the canyon, is 270 million years old. So in either case, those are really old rocks. And to put that in perspective, if the entire history of Earth is about 4.5 billion years old, and you figure the canyon is a bit less, the basement rocks are a bit less than half the age of the Earth, one day, which is 86,400 seconds, is equivalent to a recorded human history of only 2.5 seconds. So that means this talk, although it seems really long right now, is a blip, insignificant and meaningless, but hopefully you'll get something out of it. So to talk more about this pattern process paradigm, again, this gets back to the Hubble image, and you may think, why am I talking about the universe when we're here on Earth? But remember, processes that took place billions of years ago are actually influencing our everyday lives. I've done some teaching over the years, and it amazes me the number of college students who can't tell you which way the sun travels through the sky. And remember, our Earth circles the sun in an elliptical orbit, which influences, creates our seasons, and the tilt of the Earth also has an impact on solar radiation. And that has a direct impact and indirect impact on what we see in the world around us. So this image was taken somewhere in the northern hemisphere, and on the north aspect you have vegetation that is better suited to more mesic conditions, and on the south aspect to drier conditions. Now if you're in the southern hemisphere, that gets turned around, and your south aspects tend to be your more vegetated sides, and the north aspects are your warmer, drier sides that have more vegetation adapted to xeric conditions. This is a picture I took walking up Buckhorn Canyon, which is one of the many tributaries or side canyons in the park. And this is a huge boulder. I don't know how old it is, but it's millions of years old. I don't know how long it's been sitting in that spot. But what's neat about it is that when you look in the lee of that boulder, so upstream is kind of behind the boulder, you see this depositional pattern of fine sediment and coarser sediment and gravel. And it kind of struck me that you have these repeating patterns at multiple spatial scales. So if you think about it, that same pattern replicates itself at the canyon scale. And it's the same, similar processes that create those patterns. So I find this paradigm to be really useful when I'm going out there and trying to figure out what's going on. So now getting back to the canyon a bit, we have regional scale drivers that influence what we find in the park. And we know that in North America there are 4 major desert types. And if your geography is semi-good, you'll realize that Grand Canyon sits right about there at the junction of 3 of those 4 desert types. And if you look at the floristic and faunal lists of species in the canyon, you'll realize that there are representatives from all 3 of those desert types, the Mojave, Sonoran, and Great Basin, in the park. Now, as we drill down, not only do we have regional scale drivers, we also have landscape scale drivers. This is an image of a peak in northern Arizona. C. Merriam Hart, or Hart Merriam, came up with this concept in the late 1800s, and he noticed that if you look along these altitude gradients, you have different suites of species, different vegetation types. And if you transpose this kind of concept within the canyon, our lowest elevation is about 1,150 feet, and our highest elevation is about 9,165 feet. And because of that large elevational gradient created by the canyon, created by the Colorado River, incising through those layers of rocks over millions of years, we have 5 of the 7 life zones represented here, ranging from warm desert scrub up to spruce fir forest in the highest elevations of the park. So moving down into an even finer scale, we have local scale drivers. We've got over 350 springs and seeps in the park. If any of you have had the pleasure of hiking through the park, it's pretty amazing to see. This picture in the middle upper is up Unkar, and we were doing some vegetation surveys up there. We were hiking up there, it was a hot, dry day, you're hiking through this it feels like a furnace. There's just kind of scattered, sparse desert vegetation, and then all of a sudden you come up on one of these seeps, and it's like you've stepped into a desert oasis. And not only are we happy to be there, but a lot of other species are really happy to be there. And although seeps and springs only encompass about, I think, 1/100% of the area of Grand Canyon National Park, they have 500 times more diversity than the surrounding desert areas. So not only are springs and seeps influencing the diversity of life we see out there, but native vegetation as well. We know that cottonwoods support a diverse assemblage of invertebrates, which in turn support a diverse assemblage of birds and other species. And then we have simple things like snags that provide homes for birds and mammals and bats and all sorts of things. So for those who are less familiar with Grand Canyon, you might be surprised at how diverse it is, but hopefully I've provided some context to understand that it actually is a really diverse place for multiple reasons at multiple spatial scales. And if you just look at this list, I won't go through it group by group, but some things to highlight are invertebrates. We have over 8,000 known species. That's likely a gross underestimate. And vascular species, we've got about 1,750 vascular plants, which is pretty amazing, and in fact it's more plant species than any other national park in the country. I think most people who aren't familiar with the canyon would be surprised to find that out, but again, there's a reason for that. Because of the diversity of landforms and the diversity of all these other resources that I've identified, the canyon has also provided a home for people for millennia. And this is evidenced by the rich cultural resources that we have at the park. Only about 6% of the park has been surveyed, but we have over 4,000 documented archaeological sites. The oldest known is about 12,000 years old, and a ballpark estimate for how many sites are out there might be about 50,000. So there's a long history of human habitation here. And people have been able to survive here because of that diversity of resources that I highlighted. So this might be a bit of an obtuse example, but I've seen resource management can sometimes become pretty myopic, and we tend to focus on what's immediately in front of us. We're going through life with horse blinders, and we don't really see what's happening around us. And that can be dangerous because that carrot may not be the most important thing you should be focusing your efforts on. You may also be missing some threats to yourself in the process and to the resources that you're supposed to be looking after. So this is an image of Grand Canyon National Park, and as a manager, 1.2 million acres you would think is enough to kind of try and manage. It's actually a huge landscape, and we could spend the rest of our lives just focused within the park boundaries. But the fact of the matter is that the park is within a matrix of other lands. These different colors represent different landowners, so we have lots of neighbors, good and not so good. We've got the Forest Service, other national park units, BLM, state lands, tribal lands, private lands. And what they do on their land does affect what happens in the park, and in some cases vice versa. Now, this is overlaid over that are the watershed boundaries, and for those of you who are familiar, these are code 10 watersheds. This is a system that the USGS developed nationwide. It's a nested hierarchical watershed framework. And what you'll notice is that these watershed boundaries do not coincide with the boundaries of the park. And what's important to realize is that those watersheds, because they are outlined the biophysical template, They drive a lot of the patterns and processes in the park. So if you're really interested in managing resources